You know, if you think about the quiz that you guys took, last 3 questions when you were like moving things around, completing the square, changing it into standard form, basically you had this top version where you had an ax squared, a cy squared, dx, eyf, but there is no xy term in the mix. So every time we rewrote those equations, we got conic sections, and I have an example here that is ellipse, but I could have drawn hyperbolas or parabolas. But what we're getting are conic sections that have perhaps like a vertical orientation, like this ellipse has a major axis, a longer axis that's vertical, or we got something with horizontal orientation. And up until today, don't you agree that's the only kind of conic section we ever saw? Parabolas open up or down, hyperbolas or left or right, hyperbola is the same thing, and then the ellipse either is like standing up or laying on its side, right? When we introduced the xy term, which we had never seen before, so if you go back and you look at all your stuff from last week, never did we ever have an xy term in the mix. The xy term produces a rotated conic. So where I have vertical and horizontal orientation up here, I can't really use that word for this shape. Okay. If I think about where the major axis is from major vertex to other major vertex, it's on some slanted line. So what's new in our equations now is that pxy term, and that rotates our conic. So now you know about that. You're going to be on the lookout for if you have an xy term. Okay. Well, mathematicians, thought about that. How are we going to deal with these ellipses or hyperbolas or parabolas that are at a slant? They're not vertical, they're not horizontal. And our solution, which we're going to get to here in a little bit, is, well, just rotate the whole coordinate plane. Because if you could imagine taking the black x and the black y and just rotating it a little bit, then it would sit on the major axis, right? So that's what we're going to be doing today. Okay, rotating the plane. Yay. Okay, now you also wrote this stuff down yesterday, and that's what you used in the warm-up. So b squared minus 4ac, that sounds familiar, right? Does anybody remember what that was called in the quadratic formula? Yeah, it's called the discriminant. In the quadratic formula, it's the stuff under the radical, and it would tell you what kind of solutions and how many you would have. Like, do you have 2 real, 2 imaginary, or 1 real solution? We can sort of think about it the same way like a discriminant. It tells us what kind of conic section we have if we're given that general form with the xy term. Okay. One thing I want to say about this ellipse or circle, if you ever get a negative value for your b squared minus 4ac, your answer should be ellipse or circle. You actually don't know which one it is until the very end when you rewrite it, when you rotate the axes. You might look at the equation and say, oh, x squared and y squared have the same coefficients, or they have different coefficients. But remember, none of that stuff from last week applies if there's an xy term. So you would just say circle or ellipse, and I won't know until the end. Okay, so let's get into the part of today where we're going to rotate the axis. This slide is a lot of like writing things down, how we're going to go about doing this. Then the next, we're going to do an example together. Then we're going to start one of your 4 homework problems. Hopefully get close to finishing it, if not finished. It's 10.5 rotating conics. Remember, you'll only really have to worry about this issue should you see an XY term. If you think about all the things that you've ever graphed before, you've never really graphed anything with XY terms. You graph things that look like Y equals, and then things in terms of X. So that causes problems for us. And the solution to this problem is what the title of this slide is. Let's rotate the axes so that now our axes aren't horizontal and vertical. They're rotated. Okay. And if we do that, we're going to eliminate the XY term, which means that I can graph it just like I had always graphed all my conic sections before. So your goal at the end of your problems, how will you know if you've done the algebra correctly? If your XY term disappears. If you do all this algebra and you get to a new equation and there's still an X prime, Y prime, then you have a problem. Something's not right. Okay. So notice the only difference between these equations, other than all these primes, these are like those apostrophes, not ones. Okay. Other than all the primes is basically you are missing the B, X, Y. There is no B prime, X prime, Y prime, because we're going to get rid of it. All those primes mean is, hey, this is your new X, this is your new Y, this is your new A. Those numbers won't necessarily be the same for the coefficients. And when we say new X and new Y, we mean on the rotated axes, not the original axes. Well, we got to know what to rotate through. So here's the next bit of information. How are we going to do it? We're going to rotate counterclockwise. So we're going to start to see trig back in the mix. So you've got a tangent in there. I'll review some of our trig at the bottom of this slide. But we'll decide what angle to rotate using tangent 2 theta equals b over a minus c. So those are the same values you use to decide what type of shape it is. Just plug those things in, do the inverse tangent, figure out what angle it is. Remember, you'll have to divide that angle by 2. Okay, but then that'll be the angle that you rotate the axes. So I'm going to just kind of draw a picture of what I mean so that we can kind of all get the idea here. If I asked you to draw a coordinate plane, most people would draw x, y, horizontal, vertical, and you should. Okay. If we decide that we have some rotated conic, we're going to work with the rotated axes. So let's say I solve for theta, and theta is like 30 degrees. Then I'm going to take my x-axis and rotate it counterclockwise 30 degrees. So I have a new x-axis that I'll label x prime. And all it means is the new axis. And then if I rotated x, I also have to rotate y. And I'll call that y prime. Now, when I go in to graph my conic, I'll have this whole new equation with all the primes in it. But it will be like a standard form equation that we had looked at in 10.2 to 10.4. So then I can just graph my hyperbola. Maybe it has a horizontal transverse axis, but it'll all be in relation to the red lines instead of the black lines. Basically, you'll just graph your new coordinate planes and then maybe like turn your paper, right? And count up and down and left and right and everything's the same. And the last thing is, how are we going to figure out what all those prime things are, right? What are all the new coefficients and the new x's and things? Well, we're going to have to rewrite x and y. So this is how we will get those values. we will figure out x in terms of x prime, y prime. We will figure out a new y in terms of x prime, y prime, and then we will substitute these things into the old equation. And when we work out all the algebra, there will be no x prime, y prime term because we're getting rid of it. And then our new equation will be like an old standard form. I'm just really quickly going to draw up that first quadrant of the unit circle. 0, 30, 45, 60, 90. Good thing to review. You should still know these values, right? They still won't go away after this. We'll see them in chapter 10b. In blue, I'm going to put my ordered pairs. That would be 1, 0, square root 3 over 2, 1 half, square root 2 over 2, square root 2 over 2, 1 half, square root 3 over 2, and 0, 1. So you'll need to know those ordered pairs, and you can apply those to the other quadrants if you had a different angle, so that you can do the cosine and the sine. Remember, cosine is the x-coordinate, sine is the y-coordinate. So you'll be getting answers of angles that are on the unit circle so that you don't have to use a calculator. Okay. And then, back up at the top above this, I have that finding the angle. We have to use tangent. So I'm also going to list my tangents. I'll do those in red. 0, this one is 30 is square root 3 over 3, 45 is 1, 60 is square root 3. And then when I do y over x here, I'm going to get something undefined. Undefined doesn't mean that you can't do like tangent 2 theta. It just means that 2 theta is equal to 9. Okay, let's do our example. We're going to start with an easy one. You'll have, I think, at least one easy one on the homework. And then we're going to pick one homework problem that's a little bit tougher. Work on that together till the end of the period. Okay, here's our first equation. xy plus 2 equals 0. All right, remember the xy really isn't something we've seen before when graphing. We always have x and y as separate terms, like y equals something in terms of x. So we recognize here, and we're working with conic sections, that this is some conic section with some rotation. So let's figure out what conic section it is. B squared minus 4ac. What's your value for b? 1. And your a and c? Both zeros again, so we did the one like this in the warm-up. And that is 1, which means this is a hyperbola. So I would recommend you always start with b squared minus 4ac. You want to know what shape it is so you know what your answer should look like in the end. Okay. I should have both x squared and a y squared. They're going to be x prime squared, y prime squared, and one should be positive and one should be negative if it's a hyperbola. Okay, step 2. Figure out what angle you're going to rotate your axes through. So that's the tangent of 2 theta equals b over a minus c. Well, we just did b squared minus 4ac, so we know that's 1 over 0 minus 0, which is trying to say that the tangent of 2 theta is undefined. Therefore, 2 theta must be equal to what value? Well, which angle has undefined tangent? 90. And then 2 theta divided by 2 theta is 45. So yes, 45. Side note here. Let's say I thought it was supposed to be like I do the inverse tangent and I say it's a 30-degree angle, but then I still have to divide by 2 and I get 15. I'm not going to give you a 15-degree angle because you don't know those values on the unit circle. So it should come out after you divide by 2 to be something from the unit circle. Okay, and then step 3, we know the shape, we know the angle of rotation. Let's find our new x and y's. So x we said was x prime cosine the angle minus y prime sine the angle. And what do you know about cosine and sine of 45 degrees? They are both radical 2's over 2's, right? So this one will be pretty easy. X equals square root 2 over 2 x prime minus square root 2 over 2 y prime. So that's my new x. And I got to do y. I think it's sine 45 and then plus y prime cosine 45. But real important when you're doing your homework, look back at these things. Write them down, study them, know them. You can imagine, if you write x and y incorrectly, then you're not going to get the right answer in the end. So you got to make sure you do steps 1, 2, and 3 accurately. This one will be y equals the square root of 2 over 2 x prime plus, the square, x prime plus the square root of 2 over 2 y prime. Are we okay so far? Does anybody have any questions, concerns? Now, there's some proof about why this works that I'm skipping over, right? So we're just like learning how to rotate the axis, what we need to find, the angle of rotation, how to find it. But we are not going to take the time to prove that right now. Obviously, it involves some trick, right? You could imagine there's triangles when you rotate an angle. But we're just going to say, this is how we do it, so let's do it. It's applying that process. Okay, do you see up here at the top of my equation, xy plus 2 equals 0? I need to make a substitution for x and y. In place of x, I'm going to write this. Square root 2 over 2 x prime minus square root 2 over 2 y prime. And in place of y, I write my other version. So that's going to look something like square root 2 over 2 x prime minus square root 2 over 2 y prime times square root 2 over 2 x prime plus square root 2 over 2 y prime. And then this plus 2 doesn't have an x or a y on it, so it really isn't going to have any effect on all my x prime, y prime terms. So remember what we would do with those constant terms in the last sections. Just move it over to the other side for safekeeping. So I'm going to subtract. Just move it over. We'll bring it back in, like some way to make our standard form, but we'll just leave it over there for a while. Okay, what do you suppose I might do next? Someone said it? Foil it all out. Now, I will be real honest. The FOIL doesn't look great because you're working with values from the unit circle. So you have fractions and you have radicals. But the best thing I can say is do what you need to do so you'll get the right answer. They're all, you keep using the same numbers, right? Square root 2 over 2. If it was a 30 or a 60, it'd be 1/2 and square root 3 over 2. There's only so many combinations of those things that I can actually get. So stick with it. You'll get it. You just got to give yourself space and time. So I'm going to go ahead and start foiling. My first distribution is the square root of 2 x prime times the square root of 2 x prime. If you have trouble with multiplying fractions with radicals when they're so far apart, in the margin of your paper, write it down. What is the square root of 2 over 2 times the square root of 2 over 2? Well, on the top, square root of 2 times square root of 2 is 2. And 2 times 2 in the denominator is 4. So it's 2/4. Now, you can write this as 1/2, but I will say this is my one little tip. In this problem, it doesn't really matter because we're not going to have a whole lot of simplifying because it's one of the easy versions. In the harder problems when there's more x's pies to deal with. You can work smarter, not harder, by leaving everything not reduced. If you don't reduce all those fractions, then in the end, they'll still all have common denominators, and you can add them up. If you reduce in the middle, then at the end, when you're trying to combine like terms, you might still have to get common denominators. So, I'm not going to reduce my fractions until the end. If you want to write 1/4, you can, but I'm going to write 2/4. I mean 1/2, not 1/4. Don't write that. And x prime times x prime is x prime squared. Now you don't have to have the parentheses around x prime squared. It's just me personally, I don't like the way it looks when it looks like a 12. Okay, well you know what? That's really nice because now that I've multiplied square root 2 over 2 times square root 2 over 2, I know that on this next multiply I'm going to get another 2/4 for my coefficient, right? So this is going to be plus 2/4. I got to change in term. This is x prime y prime. And then I got to go inside that first set of parentheses, grab the second term, and distribute that. So again, square root 2 over 2 times square root 2 over 2 is 2/4. This time it's a negative times a positive, so it should be negative 2/4. And then I got y prime times x prime, which I always like my things to be alphabetical, so I'm going to switch that around, x prime, y prime. And I got one more to go. This is a negative times a positive, so it's another negative 2/4. And this one is y prime squared. Okay, any questions or concerns about me foiling all that stuff out? Okay, now, some happy moments, right? What happens? X prime, y prime cancels, which it's supposed to do, right? Remember back at the top it said rotation of axes through elimination of the xy term? So we've just eliminated the xy term. This is awesome. I am very happy. If at the end, and this has to be like at the very end, if you still had an x prime, y prime term, then you would maybe have an algebra error, you rewrote your x or y wrong, you did your angle incorrectly, like something's not right. I don't have any like terms, x prime squared, y prime squared, so now I'm going to say it's okay to go ahead and simplify my 2/4 to be 1/2. Are you okay with me writing this 1/2 x prime squared as x prime squared over 2? That's like 2/4 or 1/2 times that thing. Are you okay with that? X prime squared over 2. And this one will be y prime squared over 2. Thank you.
Yep.
And then it equals negative 2. So I simplified the 2/4 to be 1/2, and then 1/2 times this thing, well that thing's really going to be in the numerator. And now I'm feeling good because it's starting to shape up more like a hyperbola, right? I've got an x prime squared, I've got a y prime squared, and they're being subtracted. Only thing I need to fix is the other side. It's supposed to be equal to 1. Since it's equal to negative 2, we would have said before divide by negative 2. I've already got fractions there, so I'm going to say multiply by negative 1/2. That's the same thing. And that multiply by negative 1/2 has to apply to both of the terms, like you're multiplying the whole thing by negative 1/2. So when I multiply by the negative, they're going to flip-flop signs, right? Now x prime squared is going to be negative and y prime squared is going to be positive. And then in the denominators, you're just going to have 2 times 2, which is 4. So I'm going to rearrange it. I'm going to put the positive one first. So I'm going to write it as y prime quantity squared over 4 minus x prime quantity squared over 4. And that equals 1. Does that look like an equation of a hyperbola? Sure does. What's my center point? What's that? The origin, 0, 0. Nice thing for you, it's always going to be at the origin. Does it have to be? No, but that will involve more work. Okay, you have to complete the square again. But yours are going to be centered at the origin. Your a squared is 4, your b squared is 4, so both a and b are 2. Will this hyperbola open around my x prime or my y prime axis? Open around the y prime, because that's the one that's first. That's the one that's positive. So we're going to graph that one tomorrow. The graphing is a little less than it was in sections 10.2 to 10.4 because we're working on a rotated axis. But there you go. Okay, now here's my suggestion for your homework. There are 4 problems. I will pick 2 pieces of paper, and I would do 1 problem on the front and 1 problem on the back, and 1 problem on the front and 1 problem on the back. You know, I don't want to like start one and then have to like keep flipping back and forth. Okay, that's me personally. And I don't want you to try to get it in like 5 lines, because then it gets really hard to like go back and find your mistakes. And it's super frustrating, right? I get it. It's really frustrating when things aren't working out, but give yourself the space that you need. So I think the homework actually starts with 15 and 17, but I'm going to do 19. You guys are going to do 19. You know, whatever is going to be your homework. If you want to do it in your notes, I don't care. If you're running low on paper, go grab some scratch from my blue basket. Copy paper, so you would need 4 of them. Just stuff. Okay, can you start with steps 1 through 3? I'll check in with you in a couple minutes. Can you tell me what shape it is?
What number is
This is number 19. Can you tell me what shape it is? Can you find the angle of rotation? And can you figure out what your new x and your new y are going to look like? This will be no calculator on your test. If right now you want to use your calculator to evaluate your discriminants, that is fine by me. I will say on the test, it's like reasonable. You can do it. Okay.
Do I times the 6 in the front or no? Like
I think
36
you
times
know
3 or is
if
it
you
6?
did it.
It's 36 times 3?
Yes, because it's 6 times radical 3, but you're squaring all of it.
Yeah, so it'd be 6 times 6 and then I go through.
And check it with your pod mates and see if you agree on the shape or the angle. That's a good idea.
We just end up like solving it. Yeah.
Stoked. What do you guys do for your tangent? tangent equals radical 3 over 2. That's not right or not?
How did you get 2?
Because the tangent, I didn't put the 2 over there, like divided the radical 3.
Oh, you can't divide by the 2 until you've answered so it's tangent of 2 theta equals square root 3.
Yes.
What angle has the tangent of square root 3?
Okay.
And then divide by 2. So like that 2 in there is protected by parentheses. You can't divide by it yet. Did you guys get a circle or ellipse? Awesome. Remember, we won't actually know which one it is until we're done at the end. When we have like our final x prime squared, y prime squared equation.
Why would it matter for a circle?
Well, so remember, like, we used to be able to look up, like a rotation.
Yeah.
Yeah, it wouldn't. Like, you won't notice that the circle is rotated at all. But you don't know if it's a circle or an ellipse until you get to the end. Well, you'll get rid of the xy. But yeah, the circle, yes, it would. It will look like an ellipse with an a squared and a b squared the same. Yes. I will say that, Pierce. You wouldn't, if it was a circle, you wouldn't have to rotate it. But you don't know if it's a circle until you're done. I will ask Mrs. Hillman and see if there's a way to figure it out, but I don't know what it is. You can, like when we talked about the ellipse, you can think they're like really within the same family. I got theta equals 30 degrees, did you?
Yep.
Awesome. Okay, using that 30-degree angle, these are my new x, my new y. Do you agree with me? Real important that we're all on the same page with those. We have the right signs. Miss Cronkey didn't make a mistake. She would be super sad if she did. I think I did one year make a mistake. I'm traumatized.
You went through the whole problem.
I'm sure. But you agree with me? Okay. All right. So now's the part where we make the substitutions, right? Okay. There's a lot more to substitute, which means there's a lot more to FOIL out, multiply. Okay, so I'm going to squeeze it in one line. 13 times square root 3 over 2 x prime minus 1/2 y prime quantity squared. Plus 6 square root 3 times the square root of 3 over 2 x prime minus 1/2 y prime times 1/2 x prime plus square root 3 over 2 y prime. It's my xy. Plus 7 times 1/2 x prime plus square root 3 over 2 y prime squared. And then I'm going to move that 16 to the other side equals 16. Just squeezed it in. Okay, so the name of that game is just substitution. Okay, you're just subbing in your new x and your new y. Now, we'll have to distribute. Okay, I'm going to start with this first one. And I'm going to rewrite it as 13 times square root 3 over 2 x prime minus 1/2 y prime. And then square root 3 over 2 x prime minus 1/2 y prime. Because if you're squaring it, you're multiplying it by itself. Now, if you know the pattern for squaring a sum or difference, you can use that pattern. But I will just FOIL them out. So, I'm going to start by doing the square root of 3 over 2 times the square root of 3 over 2. Well, that's just 3 over 4. So I'm going to have a 13, and I'm going to use a bracket. I'm going to do 3 over 4 x prime squared. Okay, next up, I'm going to do square root 3 over 2 times negative 1/2. Well, I'm just going to write square root 3 over 2 times 1/2 up here. That's square root 3 over 4. So, but this is a positive times a negative, so this is going to be minus square root 3 over 4, x prime, y prime. And then I'm going to do negative 1/2 times square root 3 over 2 again. That's negative square root 3 over 4 x prime, y prime. And I got one more to go. Negative 1/2 times negative 1/2 is positive 1/4 y prime squared. No, it's not. You can do it. Think about how smart you are to be doing this. You're a little Algebra 1 cells back in 8th grade. You could do this. You can do this.
It's gotta be it.
Yeah, there has to be easier doing this.
I'll show you the pattern for squaring them here in just a little bit. Okay, these two don't cancel yet. The x prime, y primes will cancel eventually, but right now we can just combine them. How many negative square root 3 over 4s do we have? We have 2 of them. So this can be written as negative 2 square root 3 over 4 x prime, y prime.
So would you not simplify that to rest of your routine?
No, because in the end, like I'm going to have x prime squared, x prime, y prime squared from this, and I'm going to have those 3 terms from this, and I want them to all have the same denominator, so I'm going to leave it as 4 until the end. Okay, now everything there is getting multiplied by 13. So I'm going to do one last thing with this first piece. I'm just going to distribute my 13. That's going to be, when you distribute 13, it just goes to the numerator, right? 39 over 4 x prime squared. And then 13 times negative 2 is negative 26 square root 3 over 4 x prime, y prime. And then 13 times 1/4, that's plus 13 over 4 y prime squared. Now I'm going to put this like in a blue box. I'm going to put like a little asterisk next to it. So I know I've like simplified that one, like combined the like terms, distributed the 13. It's ready to be combined with other x prime squareds or y prime squareds when I do the others. Okay. Does anybody have any questions so far?
Assuming there's not going to be that many problems like this on the test, maybe like 1.
No, that's why your test is 2 days. Yeah, there'll be one rotation on one day.
So if you
And then there'll be like a couple problems with it.
Like you're screwed.
No, because you have like a couple problems and then the rotation, so you have that ability to make a mistake and go back and find it. Like you know things. Like remember, like there's only like on the last one. On the last one, we got 2/4 every time. If I'm multiplying square root 3.
I looked down for a second.
Oh, sorry. If I multiply square root 3 over 2 times square root 3 over 2, or square root 3 over 2 times 1/2, like there's only so many numbers I'm even allowed to get. So if you can't like look back at your work and try to find a mistake, that's you being lazy at this point. You didn't get here by, nothing. Okay, I'm going to do the next one. I'm going to do 6 square root 3. Now, I'm going to have to FOIL this one out again. So this is going to be square root 3 over 4 x prime squared plus 3/4 x prime y prime minus 1/4 x prime y prime minus square root 3 over 4 y prime squared. So this is going to give me square root 3 over 4. This is going to be 3 over 4, 1 over 4, and square root 3 over 4 negative. Yeah, because I want to try to get closer to being done. You guys are just complaining, so I'm ready to move on.
Okay, that's fair.
Is it fair? I think it is fair. We spent way too much time talking about it. Okay, now again, the x prime, y primes don't cancel, but I can combine them. 3/4 minus 1/4 is 2/4 x prime, y prime. And then I wanted to do this one so you could see, like, we are going to distribute the 6 square root 3. So, like, just take your time. What is 6 square root 3 times the square root 3? Well, that's really just 6 times 3, which is 18. So we have 18 over 4 x prime squared. And then I'm going to do 6 square root 3 times 2 over 4. Well, that's just 12 square root 3's in the numerator. I can multiply 6 and 2. So plus 12 square root 3 over 4 x prime y prime. Remember, I'm not going to simplify anything until the very end, because I want everything to be over 4. And then the last one, 6 square root 3 times square root 3, well, that's a negative, so it's going to be minus. And then we already did that, that's 18. So that's 18 over 4 y prime squared. Okay, now I put that one in blue because that one's done. That one's ready to get combined with other terms. So, like, I have 39/4 plus 18/4, and then I'm going to get another one that's an x prime squared on my next one that I can combine. Notice what's happening with your x prime y primes. I had negative 26 square root 3 over 4. Now I'm adding 12 square root 3 over 4, so I'm up to negative 14 square root 3 over 4. In my next expansion, I know my x prime y prime has to be 14 square root 3 over 4. Otherwise, it's not going to work out. Notice there's a 7 in front of it. So you got a pretty good chance of getting a 14 right there, right? Okay, good. Okay. And then the y's will also be able to be combined. Okay. Can you tell me what's the last one? It's plus 7, and then is it 1/2 x prime?
Yeah.
Plus square root 3 over 2 y prime?
Yeah.
Okay, I'll do on this one really quickly. This looks to me like a plus b quantity squared. Some people may know there's a special pattern that your outside and your inside terms will always be the same, so there's just 2 of them. So I could easily expand this one if you know the special pattern. This is 7 times square this 1/4 x prime squared. take 2 times both of these numbers. So 2 times 1 times square root 3 is 2 square root 3, and then 2 times 2 is 4, and that's an x prime, y prime. And then do my b squared. So if I do square root 3 over 2 times square root 3 over 2, that's going to be plus 3 over 4. Y prime squared. So if you're familiar with that pattern and you would like to use that pattern for any of those groups that are squared, go for it. If it's a minus, then the middle term should be negative instead of plus. Okay, if I distribute my 7, I'm going to get 7/4 x prime squared plus 14 square root 3 over 4. That was what I wanted, right? X prime y prime plus 21 over 4 y prime squared. So what should happen is all my x prime, y primes are going to cancel. I'm going to add up the 39/4 plus 18/4 plus 7/4. That's going to be my coefficient for my x prime squared. Same thing for y prime, and then this was all equal to, I think, negative 16. And then in the end, divide by negative 16. I'll post a finished version of that with my notes. But you have 3 more problems. Everybody can do steps 1 through 3. And then just get started on that algebra and go as far as you can until you run into trouble. But some of you will get it, no problem. Give yourself space. Give yourself time. Yeah.
Would you be willing to do